You're listening to Tech Innovator, the podcast dedicated to cutting-edge technologies brought to you by the IEEE Techverse of Sri Lanka.
Hello everyone, and welcome back to the Tech Innovator podcast series, proudly brought to you by IEEE Techverse Sri Lanka. We are excited to embark on this new season, building upon the success of our previous 3 seasons. You are tuned into the 4th episode of Season 4, where we continue to explore the frontiers of technology that are shaping our world. With the Tech Innovator, we bring you to the latest cutting edge and leading edge technology. Today, we are shifting gears to another equal impactful topic, space robotics. I'm your host, Chamali Wedage. And today, we are diving deep into the world of space robotics with a true expert in the field. Joining us, Mr. Bhanuka Dayawansa is currently serving as a lecturer in Mechatronics Engineering attached to the Curtin University Colombo, as involved postgraduate research at the Department of Electronics and Telecommunication Engineering at the University of Moratuwa. He is also serving as the Vice Chair of the IEEE Industry Application Society, Sri Lanka chapter and the Vice President of the Section C, Sri Lanka Association for the Advancement of Science. His main research interests include robot control, optimal control, and orbit manipulation and state estimation in robotics. He has authored and presented several papers in these domains as well. We are thrilled to have him with us today to share his insights and expertise on all these things about space robotics. Mr. Bhanuka, welcome to the show.
Good evening.
Good evening, sir. Once Trevor Paglen said, anything humans can do in the space, robots can do better. Space robotics is a branch of technology that focuses on the development and use of robots to assist in space exploration, research, and operations. These robots are designed to withstand an extreme conditions of space, aiding astronauts, performing repairs, and conducting scientific missions in environments where human presence is limited or impossible. They played a critical role in space missions, from exploring distant planets to maintaining satellites in Earth's orbit. To understand its current landscape, let's start with the expert. So, what initially drew you towards robotic manipulation in space environments in particular, and what considerations need to be made in designing robotic system for zero gravity conditions?
As you correctly mentioned, the human interaction when it comes to robotics in space is very limited. That's one of the biggest things that makes robot design and robot control in space a big challenge. So this challenging nature of space robotics is one of the biggest things that made me join this research domain, because when it's challenging, the scope of research is very high. There are sort of undiscovered avenues and domains in space robotics which we are yet to explore. So that is one of the biggest things. At the same time, I have been involved in robotic research some time, and it is a very widely explored area currently. If you look at the global context, probably you might have seen the Tesla's new robots, the humanoids. So you can see we are rapidly evolving when it comes to the robot technology in Earth. But when it comes to space, we are still lagging behind, because one of the things is it's very costly and it's a bit extreme environment. There's zero gravity, there's vacuums, there's a vacuum over there, and there's radiation, cosmic radiation. It makes traditional robotics far less effective when it comes to space environments. And also when it comes to the robot movement and control, in Earth, the gravity and friction factors help the robots, stabilize the robots. But it's not there when it comes to, it's limited, and it's different when it comes to space environments. So that makes space robotics a challenging field. At the same time, with the space industry growing, so you can see now, once again, if I get back to SpaceX, they launched, they are planning to launch space vehicles, and they're planning on colonizing, the space. And as the avenues in space industry keep blooming, the requirement of space robots also can increase. The reason is it's not possible for humans to go and work in space as they do in when it comes to servicing, when it comes to other operations. It's definitely going to be the robots who will be performing these tasks. So with that, space robotics is going to be one of the key areas in robotics, in particular in engineering. That's going to be highly sought after in the future. So I actually got involved in this particular on-orbit manipulation research thanks to I had to acknowledge Professor Mohan Munasinghe from the Department of Electronics and Engineering at the University of Moratuwa, who actually got me into this particular research, where we were planning on designing and developing a control strategy to a 7 degree of freedom manipulator that has been sent out by a defense company in the United States called Northrop Grumman. They have a subsidiary company called Space Logistics, where they are planning on extending satellite life cycle. So that particular research was the area that I got involved in. So that is how I got involved in space research.
Thank you so much, sir. So when it comes to space robotics, is it same the robots we see in the Earth, or is there any particular differences? Can you please explain that?
When it comes to the definition of robotics, the International Federation of Robotics has certain definitions given by defining what types of robots are there and the classifications. So in general, we can categorize the robot based on the locomotion type as well as the type of application it is used. So if you look at the locomotion, there are robots probably might have seen in industrial context where the base is fixed and the robot is moving around in a fixed area. But when it comes to mobile robotics, that's a robot that's not fixed to a particular place, but it can move here and there. And when it comes to application-wise, there's industrial robots and there's service robots. So industrial robots are generally used, as the name suggests, in the industry. But when it comes to service robots, they are used for certain applications. When it comes, whether it's like wearables, whether it's like collaborative robots where the humans and robots interact together. However, when it comes to space, we use mobile robots as well as fixed-based robots, depending on what sort of application we are looking at. So the main research that I'm working on is satellite life cycle extension, where the robot is actually working on servicing satellites. So based on the robotic definition, it's more of a fixed-based robot because it's fixed to a particular entity that's floating in space and it does operations around the environment. But at the same time, there are other space robots which are falling under the category of mobile robots. For example, if you look at the rovers, I think you probably might have heard about the Mars rovers. So they fall under the category of mobile robots, where the robot base is not fixed, it's moving around, it's mapping the terrain of Mars or unexplored planets, and it's sending back data to Earth. So depending on the application, the robots can change drastically. But if you look at the Earth context, that we look at robots, it's still applying to space industry as well. So depending on what your application is, you have to select what exactly is going to be the robot that's suitable for your purpose.
Thank you so much, sir. Yeah, I'm pretty sure even the answer to the first question intrigued our audience much more. So, as an expert in this field, can you explain current control strategies for space manipulators and robots in general and their limitations, and why one control method can be better than another?
It's a good question. So we'll first start with what control is, robot control, as I mentioned the robot control. So in particular, controlling in this context is basically we want a particular desired requirement to be fulfilled, and how that is fulfilled to what extent. That is basically what we're trying to achieve in a particular in designing a control system. So example, imagine like your air conditioner. You set to a particular temperature, and how fast and how precise the temperature is controlled by the air conditioner defines how good the control system of that particular air conditioner is. So when it comes to robotics, control has been paramount of importance when it comes to robotics because it's mostly autonomous. I will talk about autonomy in a later section, but when it comes to robotics, we want the robot to do something, and to what extent and with what precision that the robot is achieving that task is very important, especially when it comes to space environments. So traditionally, if you look at the robot control methods, we have model-based control. Model-based control means we have the robot modeled, and based on the model, we define the control parameters. So, example, we use a particular method called the Euler-Lagrange method for modeling the robot. Basically, it's like an energy-based modeling mechanism. So, if you look at traditional modeling approaches, we have the Newtonian physics, we have the Newtonian mechanics, we have the Hamiltonian mechanics, and the Euler-Lagrange mechanics. So typically, when it comes to modeling robots, we go with the Euler-Lagrange method, which is an energy-based modeling method. And once the robot is modeled, then we define the control parameters. So the problem, once again, as it suggests, we have to have a model, right? As the name implies, we have to have a model of the robot. But modeling the robot can be a bit hard. At the same time, once the robot is modeled, typically a robotic system is a non-linear system. So back in the day, what people did was they linearized the model that they obtained and then develop the controls. Example, you take something like the Kalman filter, we linearize it and we have the extended Kalman. So linearizing had its own drawbacks as well as its advantages. But as the computational power increased as in humanity, as a civilization, we had the chance to advance our controls to include nonlinear systems. That's why if you look at early robots like the Honda Asimo type humanoids, as well as now, if you look at the Boston Dynamics Atlas type robots, you see a lot of improvements in the movements. There's a lot of fluidic movements involved. This is basically because the current controllers can accommodate nonlinear models. That's the typical model-based control technique. And at the same time, currently we have AI as well in robotics. So we have another technique called learning-based control, the model-based control as well as the learning-based control. And when it comes to learning-based control, we try to incorporate AI techniques in robotics. These are the main control techniques that's currently there for robotics.
Yeah, thank you so much, sir. That is a great breakdown. And if anyone in our audience is wondering, can you please explain what is the role of sensor fusion in space robotics? How does sensor fusion play a role in improving manipulation accuracy, and what makes it crucial in unpredictable space environments?
Okay, so I'll start with what sensor fusion is. Sensor fusion is basically you are fusing multiple inputs from multiple sensors to get a much more precise and much more accurate read of the exterior environments. So I will just come into, because it's a large domain, I will just use my research as an example. So in my research, I'm using sensor fusion mainly for grasping. So if we take as an example a human whose all sensory organs are functioning very well. If you are asked to grasp something that is there, say there's a particular object like a mug or something on the table, you want to grasp it, right? So if you want to grasp it, the first thing that happens is it is there. I don't think it's visible, but imagine that there's something is there. You're trying to grasp it. So if you don't have the touch sense, you are basically looking only using your eyes. You're getting a vision input. You can see that your hand is moving towards the object and you're grasping it. But you exactly don't know, if you don't have the input, the sensory input from your skin, the amount of pressure that's been exerted on the object, whether it's sufficient for you to hold the mug or not. So sometimes it might not be sufficient. So when you lift it off, it might fall down. So it's important that we use both these sensors. The tactile, or basically tactile means the force sensing of your fingers as well as the eyes. It's a coordination between both the eyes and the skin. That's what we call fusion. So when it comes to robotics also, it's very important, especially in space, because in space, the inertial conditions, the gravity conditions are very much different than in Earth. So if I'm going to use a manipulator to move an object that is in space, in case where I'm trying to operate on a satellite and service it, if my force is not precise, it maybe exceeds a certain amount, this object might float away in space, and the robot has to follow the object and try to grasp it. It's going to be a totally complicated dynamics problem. So it's very important that at the time of grasping, the amount of force exerted is optimal, and also the speed that is approaching is optimal. So we have to plan the trajectories of the robot accordingly. So in that case, you have to have sensor fusion. And the sensor fusion technique, there's multiple techniques that you can use. I'm using this extended Kalman for this purpose. So basically, in very simple terms, you are getting multiple sensory inputs. You are using vision. Maybe you can use some other sensors also, and you can have the tactile. And you can basically define this sensor you trust more. And by that, you can do that in your filters. And whatever sensor you trust more, whatever sensor that you think is more accurate, you can have higher value given. And based on those sensory inputs, your system will operate. And by doing so, you can avoid any type of complex conditions that might occur by exerting wrong forces, wrong trajectories, and wrong robotic movements.
Yeah, thank you so much, sir. So it's really amazing how technology is advancing to integrate such a range of sensors, right? So our next question would be, how would you describe the current state of space robotics, and what exciting developments have you seen in recent years?
Yeah, so space industry as a whole is developing very largely and very fast. So you can see back in the day, we didn't see, only the NASA was operating all these things, and all of the private space companies were mostly just keeping baby steps. One of the biggest reasons is the space industry is a highly high cost involved, right? There's a lot of costs involved, and also it's a high capital industry. So the private companies were reluctant to put money into space because it's a high risk involved, and the return of the investments is not very fast achieved. But in the recent years, SpaceX has shown very promising results when it comes to space industry. And also one of the good things when it comes to SpaceX is that they don't patent their designs. It's open to the general public, so the others also can try and develop. So they have now, for example, they have the technology to land booster that has been sent out. So this technology others also can incorporate. They don't have to pay for the patent or anything. The technology is available, and they can work on it. So I think in the recent years, in the years to come, there will be a huge boom when it comes to space. Now, currently, there is a huge boom in the AI sector, which we did not expect. If you look at the natural language processing, the large language models as they have today, currently, it was not. It's basically an exponential growth, which we did not see like for 5 years back. But you can see now the landscape is changing drastically. Many things are contributing for this. The computational power, the investments. At the same time, you can see the space industry with the development of all these AI-based techniques, and also the interest people are seeing with the current trends in the space industry. It's supposed to, and it will grow. And there will be other areas like when it comes to space tourism, there are people willing to invest in these areas. And at the same time, this is one aspect. Other aspect is now, we sent out a lot of satellites and all to space. And these satellites, after a certain time, they end their life cycle. And now, this particular current phase, there are a lot of satellites that we have sent, and they are expiring. So sending out a separate satellite can be costly. It will require high investments. At the same time, it will add more debris to the space around the Earth. So it's always better to extend the life cycle of existing satellites, cost-wise, and also pollution-wise. Because space pollution is going to be a hot talk in the coming years, because the more polluted, we will not find space to send a satellite, right? So it's always important to manage the debris floating around the Earth. So this satellite life extension will be something that will be very keenly looked upon in the future. So at the moment, Northrop Grumman, a space logistics company, they are actually working on this particular project. They are sending out the mission extension pod, where the mission extension pod has a robotic vehicle. It goes and extends the life cycle of satellites. So there's going to be high, avenues, more avenues opening in space industry, as well as high impact research will be there involved in space robotics.
Yeah, thank you so much, sir. It really seems like space robotics is entering a whole new era of capabilities. So, Mr. Bhanuka, we would like to know, what role do collaboration and interdisciplinary research play in advancing the field of space robotics?
Collaboration and multi-domain research is actually not just for space robotics, but it's important for all domains. So if you take, since it's my domain, I talk about robotics in general. Robotics research cannot be done alone by a mechanical engineer or electronic engineer or computer science engineer. It's a collaboration of multiple domains. And if one person is trying to do all these things alone, it's mostly impossible. But even if it was possible, it's going to take so much of time, and probably the outcome will not be as desired in the level that he or she desires. It's always good to collaborate, and especially when it comes to space robotics, it's an area where there's going to be a lot of control is involved. Controls theory is very much involved in space robotics, because once again, the human involvement is very limited. And another thing is the communication, and also the electronics, the physics, the space-based physics that's involved. So it's the involvement of multiple domains, multiple fields, and it's equally important that everyone that's involved in this domain gets involved in this type of research, because there might be a really good engineer who is really good in robotics, but lacks the knowledge in basically space environments. So his models that he developed for robot control might not be as accurate as it is that he thinks, because he's not taking into account the space conditions. So, and also at the same time, AI is really advancing, and it's always good to go for learning-based techniques if it's possible to increase the potential of this space robotics industry. So it's not only for space robotics, but for all the areas. The future is collaboration. You cannot do research alone, as we did earlier. All domains has to take part, and the research communities have to communicate with each other and interact, so that they do more productive research to the world.
Yeah, I think that's a great point. It is really exciting to see how collaboration can push the boundaries of what's possible. So, Mr. Bhanuka, according to your research history, can you discuss the practical applications of your research beyond space, and how do you see these advances contributing to fields like autonomous robotics and AI?
Yes. So space robotics, even though we are developing a robot control for space alone, these systems can be fine-tuned and used in Earth or any other field as well. When it comes to space robotics, one key thing that we look at is the precision and the autonomy. So, because if you look at ground-based robots that we see in the industry, there's a little bit of teleoperation and human operation that's involved. So there's a human sometimes who's there, to control the robot at standby. But when it comes to space robots, it's going to be a bit challenging, because it's high latency, you cannot basically communicate real time with the robot. There's always going to be a delay, right? So there's autonomy involved. You have to make the robots a bit autonomous. So when you talk about autonomy, other fields also can, take advantage of autonomous robots rather than having human control. You can limit the human control by making the robot autonomous. And to that extent, so if we develop precise autonomous controls for space robotics, obviously that those can be incorporated in the conditions as well. So a bit of fine tuning that will require to be done, but it can be used in the ground Earth context, especially in areas like medical robotics, because medical robotics need very precise control. We cannot do any type of mistakes when it comes to surgical robots and so on. So this particular space robotics technologies can be directly incorporated with a bit of fine tuning into medical and also electronic manufacturing sectors. So, yeah.
Yeah, thank you so much, sir. That is incredible. It is exciting to see the crossover between space technology and more everyday autonomous systems. The potential seems limitless. And finally, for students or young researchers who are interested in space robotics, what opportunities do you see in this field? How can they contribute to solving these complex challenges?
Yes, so as I mentioned, space industry is blooming, right? Currently, I think there's a huge bloom in the AI sector and the computer science sector. So I think so many people are trying to join computer science backgrounds, IT backgrounds, because of this large bloom in the AI sector. These blooms, they come up, they go down. These trends, that's normal nature. Back then, there were these blooms for the construction industry. It went up, it went down. Now it's there for AI. It's going to go up. It's going to saturate at one point, and it's going to go down. I'm not saying it's going to go down and die off. It's going to be, saturated at a particular point and sustain there. And based on different circumstances, that can go up or down. And I can see in the coming years, one of the areas that's going to rise up is going to be space. Space anyway has had this particular interest in the past years as well, due to many reasons, science fiction, and also there was a time where people thought that if you can get involved in space related stuff, it's pretty cool. So because of these things, space industry has been maintaining a particular level. But I think with the current technologies, especially with the involvement of the private sector in the space industry, apart from NASA, there's going to be very high involvement in space. And also not only because space industry was involved, people involved in space industry are more centralized or localized in the US. But now India is involved, China is involved. So the market is going to widen up. The competition is going to increase, and that's going to open a lot of avenues. And space robotics, so when it comes to youngsters, there can be people who are interested in space. There can be people who are interested in robotics. So both these domains are going to grow, according to what I see. So I think you have to figure out what your passion is firstly. If you want to, if you see yourself interested in a life in the future, in the electronics sector, in the robotics sector, I think you should start now. There's a lot of resources for you to start with. Just see if you like it. And if you are really good at something, you can definitely excel and you can definitely find placement in that area. So start working on that area. Just do some projects. There's a lot of open avenues now. If you want to just join a research group as a volunteer, you can do it. Help, some people who are involved in research, get your hands dirty, build something. It might work, it might not work, but that's how you learn. You have to fail first, then only you learn. So there will be a lot of avenues and doors opening in the future. And at the same time, AI, of course, as I mentioned, model-based control is now, we are still working on model-based control, but if you want, we can still, we have the chance of going to AI-based control as well. So if your field is in AI, then of course you can plug that into robotics. So whatever your field is, if you're good at it, you can, pivot these areas. First thing is, I think, learn your fundamentals properly. So once you know your fundamentals well, then you can divert or pivot into whatever area that is actually blooming at that time. So my advice, if I summarize, you have to be good at one area, learn your fundamentals, get your hands dirty, do your work, and then look at the opportunity that's rising up, and don't be afraid to take challenges.
Yeah, thank you so much, sir. I'm pretty sure our audience was eagerly waiting for that answer. So, finally, we had a great discussion with you, Mr. Bhanuka Dayawansa, and we would love to know your perspective on our podcast session, and your input will be so much valuable to us.
So it's actually, I have to thank God because I have been involved in multiple talk sessions, but it's the first time I got a bit technical and spoke about this research area. So it is good to have such a thing because, it's key. One of the key things of knowledge is disseminating. You are just keeping it for yourself. And then the public will not know what's going on. And making a podcast actually, and getting, individuals and people who are, involved in a particular research area or particular industrial area will help him or her to disseminate the knowledge that he's working on. That will actually get people who are interested to, branch out from there and improve the particular domain. In the end, actually, what we're looking at is a more advanced community and whatever the service or outcome that we can do to the community. So by making knowledge more widespread, the areas that's going to branch out from the knowledge that's already there is going to expand. So I'm thankful for you all for doing this. You are basically spreading out knowledge among Sri Lankan youth and as well as the global youth. So there will be more exciting areas branching out from the existing research that's going on. So it's a good job.
Thank you very much, Mr. Bhanuka Dayawansa, for sharing your expertise with us today and helping our audience understand the advancement in space robotics. So, listeners, we hope you enjoyed this episode. If you are interested in learning more about the latest cutting-edge technologies, stay tuned with us through our podcast platforms, Spotify, Apple Podcast, and YouTube, as we have many more sessions lined up for you. Until next time, I'm Chamali Wedage from IEEE Techverse Sri Lanka, signing off from this episode. Stay curious and stay tuned for more explorations in the ever-evolving world of technology. Goodbye. Thank you, sir.
Thank you.